Good days, ladies and gentlemen. My name is Elena from Hwa-Seng Builder, or HSB in short. HSB is a local homegrown Singapore civil engineering contractors started by my MD Mr. Thomas Ng 30 years ago in 1992, starting from scratch to our current workforce of about 400 staffs. Over the years, we undertake all aspects of civil engineering projects including golf course, construction of aircraft parking bay, taxiway widening, expressway widening, bridge construction, MRT viaduct and station, and vehicular tunnel construction. We have prided ourselves as a progressive company and over the years embarked on various smart technologies to aid our construction work. We have our own training center to train our workforce on various safety and health aspects with the aid of virtual reality room to simulate real work activity on site. We adopted electronic permit to work system to speed up permit application process, which can be time consuming. We also believe that a healthy and committed workforce is a strong workforce. We continue to engage the staff regularly and provide support to them so that they remain motivated and committed. Today, I'm both honored and excited to be able to share my experience on driving BIM and smart construction technology in Singapore roads infrastructure projects from a Singapore contractor's perspective. I'll share with you on the major challenges on Singapore's road infrastructure projects, give you a general introduction on how BIM comes into the field of road infrastructure and what makes it unique, and a glimpse of our project workflow adopting BIM and smart construction technology using the famous slogan of building twice, once in virtual, then in reality. There are three major challenges in Singapore's road infrastructure projects, namely 1. The existing underground utility services, the existing traffic condition, the proximity to residents and building while works are being carried out. Singapore has 733 square kilometers and approximately 5.5 million population. In a land-scarce Singapore, all our utility services, including our water mains, electrical cables, telecommunication cables, etc., are all buried underground to free up livable space and maintain pleasant aesthetic of the city. This has inevitably increased the complexity when construction work is to be carried out in a highly urbanized area. All the utilities are critical infrastructure and must be protected to prevent disruption to the daily livelihood of the city-state. Most of our road infrastructure projects involve widening of expressway, new link road through construction of vehicle viaduct, flyover, tunnel, or new arterial road for new towns. To prevent damages to these services, utility services plans are purchased, confirmed on site, and plotted to the BIM drawings, overlaid to the permanent structure to be constructed. This will enable early intervention when clashes are detected in the virtual world to make adjustment to the permanent structure, and in the inevitable to divert these services away to make way for the construction. Diversion of these utility services are often costly, time-consuming, and destructive to the general public due to the shutdown of services, and is therefore imperative that the work is carried out safely without interruption to these utility services. There are 9,000 lane kilometers of road in Singapore, which equates to about 12% of our land space to cater for the approximately 970,000 vehicles. Therefore, it can be expected that working on this carriageway poses imminent challenges. Any unplanned shutting down of the carriageway will inevitably result in a slowing down of traffic, resulting in traffic jam and leads to frustration. Careful planning during the work is therefore critical to ensure that there are always lane-for-lane replacement when work needs to be carried out, or work can only be carried out during off-peak hours when traffic volume reduces. In a highly urbanized and matured city in Singapore, most of the road construction works are carried out in close proximity to residents or commercial buildings. Construction noise and dust generation is of great concern, especially in today's context where more and more people are working from home. Careful selection of smart construction equipment with low noise emission in conjunction with higher productivity machinery to shorten the work duration may be necessary to address this concern on noise and dust generation. In consideration of all the challenges that I have mentioned, we need to have more accurate information, location of such utility services, and surety to ensure that the work can be carried out with the least disturbance to the motorists and all the stakeholders around the construction, ensuring that there are no damages to the utilities during construction work. A comprehensive model incorporating all these challenges and constraints on site must be made available to the project team to have full visual when work is being carried out. This is when technologies come in play to aid the construction work to be done safely with surety. As part of Singapore Land Transport Authority master planning to provide better road connectivity between towns and expressway, HSB was awarded a contract to build a vehicular interchange and a series of link roads connecting Punggol Town to Pasir Ris Town and provide faster connections to the expressway. When we embarked on the project, we decided to develop a BIM model for the entire bridge with 3D BIM. The drawings in PDF copy were digitalized from 2D flat drawings into 3D BIM model using Autodesk Civil 3D to capture all topographical survey of the ground in reference to the profile of the link road and bridges. The structural frameworks were then input into Navisworks with duration and construction logic to produce time-based construction program and sequence of construction. This sequence would then incorporate Google Map and statics photo to generate perspective, fly-through videos of specific work sequence using Lumion software for visualization. As the model develops, our structural consultant then input their structural element into the bridge details. Using a host of different 3D modeling software, including Revit, Tekla structures, this model develops the construction drawing and the reinforcement bar details. In consideration of the site and time constraints, major bridge components, including the bridge columns, piers, and beam, were prefabricated offsite. To ensure a perfect fitment between the precast component and the cast in situ structure done on site, our BIM model was shared with the prefabricator so that they have accurate information to ensure fitment on site. Using Tekla's structure software, bar bending schedule can be generated and shop drawings for precast component can be produced. As details are being developed, regular technical discussion and sharing of the BIM model to discuss the clashes detected virtually and solutions to overcome these clashes. These sessions are critical to ensure that this precast component weighing up to 100 tons can be smoothly installed onto the cast in situ structure on site without drama. The completed shop drawings were then shared with our in-house engineering team for evaluation and fitted virtually to the cast in situ element on site to ensure fitment without clashes. Using data from the Navisworks, the production line will adopt an DFMA technology to do a just-in-time casting based on forecasted launching date to reduce storage facilities and avoid double handling process to improve productivity. Virtual walkthrough using virtual design and construction software are then developed to build the construction sequence virtually. All different stakeholders, including the clients, launching specialists, precaster, and the auxiliary police are invited for the virtual walkthrough together with the project and supervision team. This ecosystem ensures everyone in the supply chain is clear on the actual process of the work and provides feedback on any risk or shortfall they may have observed during the virtual walkthrough. Once all the major foreseeable risks and clashes are addressed and resolved, the actual work progress can start without surprises on site. From our experience using BIM and smart technologies for our projects, we are convinced that there are notable time and manpower saving from using these technologies. The wide use of integrated BIM models to share across the entire ecosystem with all our stakeholders allow us to have better visualization and reduce error due to the use of wrong or obsoleted drawings. The integrated 3D BIM model were also able to layer the existing utility services over the permanent structure to be constructed, giving the project team more visual and allowing for proper planning in the services protection during work execution. This is important so that the disturbance to the utility services are kept to the bare minimum. The use of smart technologies, including sensor and artificial intelligence CCTV, further enhance the safety of these services. The use of virtual design and construction, or VDC, where construction sequences are detailed in animation, has the capability to view the actual construction sequence from all angles, to identify and deconflict any clashes virtually. Having building it once virtually, the project team can cut down the learning curve process on site and construct it on site more safely. The use of VDC also allowed the project team to plan for optimized site utilization requirement and reduces traffic diversion required for the work. In the event road diversion may be necessary to be carried out, the BIM model are able to work out the proper vertical and horizontal curvature of the diverted road with optimal site distance. This ensures that the traffic flow remains smooth and safe. Having the structural component manufactured in a controlled environment of the precast yard, we are able to eliminate long exposure of our staff working in harsh conditions on site, resulting in the intangible benefits of a safer working environment. With the reduction of cast in situ work on site, lesser dust and noise are generated. This results in a more bearable living environment while the construction work are being carried out. This will definitely lead to a more cordial relationship with the neighboring stakeholders, which are crucial when working in close proximity to these residents. Together with the use of VDC, BIM, and precast construction, we were able to significantly reduce time and manpower and completed the vehicular interchange and link roads project in Punggol projects up to 1 year ahead of schedule. The adoption of BIM and VDC has also enabled us to have better planning when we are tendering for projects. Using a host of software, we were able to envisage the methodology to be used and design out the risks. By eliminating all foreseeable risks, we are able to tender with more certainty and complete the project safely and timely. Looking into the future, HSB is committed to embark on integrated DFMA and integrated digital document management system to execute our projects in a more professional and sustainable way. The use of management software provides full BIM integration, QR code generation for all precast components, which can be used for tracking the production, delivery, and actual installation process. The management software with real-time progress updates can provide graphical presentation of actual progress versus planned work for easy visualization and progress reporting, which will further reduce manpower and improve efficiency in project management control. Once the completed components are installed or completed on site, the work status would be updated automatically in the baseline program to reflect work done. The use of such digital solution will greatly reduce the reliance of manpower for updating of work progress and improve productivity, while the project team can be better deployed for more productive and critical work activities on site. Over the last few years, information technologies improved leaps and bounds. With the rollout in the 5G networks, the impossible has been made possible. And while laying bricks and mortar remains, the methodology we use to do it can be streamlined and improvised, made possible with technology. Construction must not be the 3D that we know 20 years ago. Dirty, dusty, and dangerous should not be synonymous with construction. Rather, digital, dynamic, and desirable should lead the way. I'm excited to be able to witness this 3D transformation, and I invite you to join me to embrace this better, brighter, and breathtaking transformation journey together. Thank you.